specific feature of your Fast API is your data validation, right? So it automatically does that. Data validation is something that it automatically. Next, this is with respect to your web framework. Okay. Now you will have your code, right? Your entire ML code, and then you will have your web framework, REST API commands. This is going to be like a wrapper around your code, right? And you know how we have done the coding in Flask also. You'll have the entire web interface, the API code, this is being defined, and then within it, in the custom function, you can use your ML models. The same models can be used for prediction purpose. Same logic will be applied here also. Now, once this application is ready, let us assume the ML code is ready, the Fast API web framework or REST API is ready. Then, in the last session of the series, we have used Heroku Cloud. It's a platform as a service that is available, and you're going to push your code into Heroku. And there you will get the edge point and all those things, the URLs and all those things are available. But what if I want to deploy my application in a different platform? Not in Heroku. Heroku is like a readily available platform. But from a client perspective, let's say as a client, I want to do this deployment in a different server altogether. I might have development server, I might have production server, I might have test server. These servers could be on local, these could be on cloud. We don't know what could be the client requirements, right? So we need also that flexibility which allows us to take our final code and deploy it in different servers. The biggest problem with this is this one. I mean, just to add some humor, no disrespect, but if you remember this display of the vehicle, the Elon Musk, the car, the future car that we talked about, on the stage, when the challenge was thrown, right? On the stage, the glass cracked. They said that the glass would never be broken. It's unbreakable. That was the claim. But on the stage, on the launch, it did not work. Right? So this is a classical problem that we will have. Your ML, right, engineers, they will develop your ML app. They test it, they do it, and right, they probably validate it, they measure the metrics. Everything is done on their system, whatever the server that they are using. Let's say server one, or I'll say development server. So it works on this particular development server because as part of the development, we will require all those dependencies, right? And those dependencies are ensured that are available. Now, these dependencies could be hardware-related dependencies, software-related dependencies, or OS-level dependencies, or app cross-functionality-related dependencies, right? Could be anything. We don't know. So from a development perspective, we will ensure that these things are anyways addressed while the development process is happening. Now, if I take the final application and do this on test environment, or for that matter, if I have a production environment, then, so I'll talk about test server. This is a different hardware altogether, right? So we'll talk about production server. The problem is there could be different hardware or software standards being maintained in test server and production server. It's not mandatory that your development server, test server, and production server should be identical. Different organizations have different standards. They do not shell too much of money on development or testing servers. But production servers, definitely they will be very high configured and they're powerful basically. So in such cases, because literally physically these computers, these servers are different, the application that you developed in one system may not work in another system. This is the biggest challenge with respect to your any application development. Now, ML is no different in this area. You'll also feel the same problem. So this is where we will have the Docker coming into the picture. So what is a Docker? And what is Docker to start with? So you can see Docker is basically a very simple software, and it allows us to create, deploy, and run applications on any server. All we need to have is that software installed, irrespective of the hardware and software requirements or standards that these servers are maintaining. This is done using something called as containers. Now, last session we have briefly touched based on what does containers means. But yeah, next slide I will talk about that. Now, Docker is a software which is OS independent, right? And platform independent, you can say. It can run on local, it can run on cloud, it is Windows, Mac, Linux, right? So it works on any computer. All you need to have is a Docker software. And we will have this Docker engine. And this Docker engine is responsible to generate our runtime environments. So it initiates your application containers. These application containers are running as if they are supporting the services on any server. Okay, so Docker engine is responsible for giving us the runtime environment. And it's basically a software, or you can say a platform, which is available as a service for various products. And what does it do? It does OS level virtualization. When I say virtualization, again, we literally go for virtual machines and all that, but containers is completely a different concept. So OS level virtualization is done, not at the hardware level virtualization. And these OS level virtualizations are called as containers. And these containers are completely disjoint, isolated, independent. And each container will have its own requirements and everything. Basically, all the related artifacts are available within the container. It kickstarts the containers based on the requirements document that we have. All the dependencies that we are required are also documented in it. So taking all those OS, even OS related dependencies to run your application. This way, irrespective of where you are running, your application will run. The server could be anything. So that is the advantage of having your containers. This is basically the demonstration. You can see the image which speaks about your containerization or containers. So as we discussed, a container is nothing but a software. Again, it's like a software, which is, you can say at BIOS level, you can imagine, is a standard unit of software which allows us to package the application and related dependencies. Right? Now, if you package everything together, then application runs in any operating system, in any computer, because it has all those things which are required. Right? It does not depend on the operating system or any other softwares that are running on that server. This itself is like a standalone application which can run. It just needs a hardware. That's all. So as we seen in the last slide also, it is nothing but OS level virtualization. Okay. And it does not require VMs. So if you look at this image, this is your containers technology. This is the logic. This is where your hardware is, right? Your system resources, you can say, hardware resources, you can say. On top of the hardware, you will have operating system. In the operating system, you'll have different softwares. You'll also have Docker. So the Docker engine is, right? Of course, this was initially started with Linux operating system, but later on it was developed for all the applications, Windows operating systems also. Microsoft has spent a lot of time to give this kind of a feature, Docker engine feature, right? Containerization feature for Windows applications as well. Windows operating system, I should say. So the Docker engine, which is sitting on top of OS, it could be, as I mentioned, Mac, it could be Windows, it could be Linux, different flavors. Irrespective of that, what it is doing is when you are trying to create a container, it takes all the dependencies that are required, the application, and along with this application code, it also packages the library files that are required or the binary files that are required to gather all those dependencies which require for this application to successfully run. Now I can create multiple containers like this. These are independent. This is a separate application. This is a different application. All of them are running on the same server. All of them are consuming the same hardware resources. Right. So this is the containerization image. And the application that we're speaking about, the containers, they contain all the runtime components which are required. Everything, the files, the softwares, everything are packaged together. Okay. And the advantage, as we discussed, it doesn't split your hardware virtually. Hardware is same. At the OS level, you are splitting the containers separately. This is basically how your Docker image or snapshot can be built. And using Docker engine, we containerize that particular image. So the Docker image is basically nothing but the package. Everything that we speak about, right? That is nothing but your image. And this contains everything that is required for your application to successfully run. When I say everything, all the dependencies, the OS related library files or binary files, the application related dependencies, there could be version mismatch issues, right? So what version of the application you are using, all those things are packaged together along with your code. And then we simply put this image, we build this image, right? And then we register this image into the repository, standard repository. We call this as Docker Hub. And from there, whenever we want to use that particular image, we can containerize that, right? So we can say, start container run. This is going to allow us to have the application as a standalone container. And this container can be used for accessing the application or accessing the functionality of the application. And yeah, it doesn't have any shells, interactive shells, right? It has to be through Docker image itself. And these images do not consume a lot of space. That is another advantage. And community is very, very huge. And you can see the Docker Hub. You can just Google for it. There are millions, huge number of Docker images that you can readily access. If you are already familiar with Python programming, then I would say Python packages, pypi.org. I'm just trying to draw some synergies, friends, here so that you people understand. pypi.org is the centralized repository for Python. For Docker, you have Docker Hub. Here you'll have a lot of packages. Here we have images. This is also public community based. This is also open source, public community based. Right. So this is how we will have, and we will, whatever the application that we are developing, we are going to convert that into an image, and we can place that into the default Docker Hub. You can also have customized Docker Hubs, and every cloud platform has their own repository for these images. So this is basically how your Docker image can be run. You'll have a Docker client, command line interface. There we basically try and create the image, and then we try and start the containers, right? We kickstart the containers. So we build, we ship it to the repository, and then from there we run it. So that's how your Docker containers can be started off. Now let us look into the hands-on. Okay, so I would request my colleague Aditya to share the screen. Unfortunately, I'm not able to showcase the entire deployment in my computer. So I requested my colleague to share and walk us through with the implementation. So yeah, Aditya, please can you share the screen and share the code, please? I will be talking about the the entire application. I'll quickly walk you through with this code. So you can see there are these libraries from FastAPI, import FastAPI, then from PyDantech, we are importing the base model. The Pickle software, the Pickle library is for saving our model and loading our ML model. Then we have the usual NumPys and Pandas libraries. And Unicon is also something that we need for instantiating and running your FastAPI application. There is one question. Let me take up the question. What is the difference between containers and image? Okay, so image can be seen as the software code. So in the Docker, we are basically having the application, right? The code. Along with the code, we will have requirements document. We will have standard Docker file, which basically documents the requirements. Post that, when you want to use that image, you need a service, right? I mean, it has to start. It has to be servicing your requests. Image is like just a code, and container is like your executed service. Functionality can be accessed through containers. The code will be the image. Okay, so it's like image is the code, and containers are like your executable application, which is designed from this code. Hope that answers your question, Sahil. Moving on, this is the application instantiating. Line number 8, we say app is equals to FastAPI. This is how our application is named. And here we are defining the base model. The application that I'm talking about is the fuel efficiency prediction example, which we have seen in the last session also. We will be looking into the bunch of input fields. We're reading the input fields. And here we see the MPG prediction. This is the custom function which will be called in when we say post. Right? So the post function, as we've seen, right? This is one of the operation which will allow us to create the data and access it, right? So get is to read the data, but here we are trying to create the data. I mean, post. When you say predict, it generates that data, right? So that is the logic here. And the custom function that we are triggering is calling the base model, which reads the inputs. Now, once the data is in read, we use the saved model, the model._pkl pickle model. I'm loading that pickle model and using that model for doing the prediction. Right, so accessing the data, then converting that into a data frame, then using the predict function to do the predictions. And these predictions are written on the screen. The default URL is the local host when you initialize your application. And this is, as we said, is using your Unicon service and prints the outcome. Now, can we go to the Docker file, Aditya, please? Yeah, so this is your Docker code, friends, Docker image file. It starts with the Python version. The current version that we are using is 3.9 in the system. Then you will have the buffering statement environment. Basically, it is for stopping the Python buffers. This is by default, it's there. Then we have the OS level dependencies. It ensures that your Ubuntu server, we are using Ubuntu here. Operating system libraries are Ubuntu. So Ubuntu packages are updated. Right? And then we are trying to ensure that the pip software is always up to date. So within the image, we'll always ensure that we'll have the latest of the pip software, because it has to internally bring in all those Python dependencies that are required. Then we have the current working directory. We've defined what is the current working directory. We give a name. Within that working directory, we will have requirements. We are copying that file there. And then we have um, the install command, which looks into the requirements file and then installs all those dependencies that are there. And then we are copying the entire thing into the main folder, the current working directory. Right. And we run the model here. Line number 29 basically says run the Python application. And right, this is basically going to give you a container which is exposed to the external environment via the port number 880. We are exposing the application to the external world using the port number 8000 by default. Here it is 880. All right. So this is basically the code in Docker file. We don't have, right? You can see we don't have any big coding requirements here. All the dependencies are done, and then finally at the random line number 29, we are executing our actual Python code. The model.py is your ML model that we have. So it executes that. And within the model py, we are also, right, within this, we are also trying to bring in the FastAPI. So this is about your Docker file. Now let us try and instantly initialize this Docker image and create a container. Can we go to that command prompt and run the lines? So we'll use Docker. We'll have to install the Docker software. Yeah, we can go to the current working directory. The folder where our right, software is there, we will have to redirect to that folder. That's basically your current working directory. Yes, this is our location. And you can see we have pickle file, we have the Docker file, we have our model.py where our FastAPI application is also. And yes, Docker. Then we are trying to build Docker build -t. And then you have the name. Yeah, this is the name that you want to give for your image. And 1.0 is the version. And then we execute it using the dot. That's the current working directory, right? So we use that dot to kickstart. This is going to create a Docker image. Let us execute that. So it is building the image. You can see it's right, taking steps one after the other and installing everything, and then it is throwing the error. Requirements.txt is missing. Yeah, let's just check that. Yeah, can we just copy that requirements.txt file into the folder and rerun the image, please? Okay, done. So yeah, so once the requirements document is updated, it is now executing fine, right? So you can see the Docker image has been built. Now let us initialize the container. Can we start the container now? Yeah. So you can see these are the images. So you say Docker image, the ML-deployment, the tag is 1.0. That is the image that we have created, and we have image ID also. Using the image ID, we will now start the container. Yeah, Docker container run and the image ID. This is going to initialize our container. And you can see the right URL there. So the application is up and running. Can we also see the Docker containers running? You can probably take another terminal and just run the Docker commands to see the images that are running, the containers that are active and running. And yeah, you can also show the UI. Yeah, Docker container. ls-a, listing everything. A means all. And yeah, this is the container that we just have initialized 47 seconds ago. Now, can we show the UI also for this particular application? With respect to the time, right? So we don't have much time, so we can just show the FastAPI application. Yeah, so this is basically what we are looking at, friends. You can see the predict is the tag, and you can see the parameters. The schema is something that it is validating, request body, and these are the right example values, right? Yeah, so this is basically the inputs that we are passing. So using the FastAPI UI only, we are trying to do the post, and then we'll execute it. And right, this is going to give us the final result. It's redirecting to that /predict. And once we go to that path, the code is getting executed and we are seeing the result. Right. So this is how we can deploy. Of course, the UI can be enhanced. We can also use our own templates rather than using the FastAPI standard templates. We can embed our own templates and then showcase the UI much beautifully, whatever applications that you want to add with respect to user experience or user interface, we can do that. This is a very simple sample code that we are running through so that you can understand how FastAPI and Docker can be used for deploying the applications on any system. Now, what we are doing is we are initializing the Docker container on our local machine. You can have the Docker software installed on your cloud, any cloud platform, and then connect to the Docker Hub, which is your standard repository. You have already initialized the image. You have registered your image there. You just built the image here, but you have to register it. Once it is registered, it will be there in the Docker Hub. And irrespective of where you are accessing it, you will be able to get the image. And then from that image, you'll be able to deploy your application. So this gives you the flexibility, right? It basically allows you to work with your ML deployment without having any dependencies on your hardware. So this is the benefit. And with respect to the deployment, we have successfully seen how FastAPI can be used in place of Flask and Docker can